Hi guys, welcome to my channel. In this video we're going to be looking at a challenging question from the STEP examination involving the roots of polynomials. So let's get straight into it. Let alpha, beta, gamma and delta be the roots of the quartic equation x to the 4 plus p. Determine a. So the first thing that we know is that a is the negative sum of the roots. And in this case the sum of the roots is alpha beta plus gamma delta plus alpha gamma plus beta delta plus alpha delta plus beta gamma. But what we also notice is that in the original equation, this is going to be equal to q. So therefore, a equals negative q. So now we're told to consider the quartic equation given by p is 0, q is 3, r is negative 6, and s is 10. In other words, that's the equation y cubed minus 3y squared minus 40y plus 84 is 0. I'm going to call that f of y. Now we see that f of 2 is 8 minus 3 times 4 minus 40 times 2 plus 84, which is 8 minus 12 minus 80 plus 84, and that's 0. So by factor theorem, y minus 2 is a factor, so f of y equals y minus 2 times something. We know the leading term is going to have to be y squared. That's created a negative 2y squared term. We want negative 3y squared, so we're going to do negative y to create that negative y squared, which creates a plus 2y. But we want negative 40y, so we're going to have to subtract 42y. So our last term is going to be negative 42. And that factorizes to y minus 7 times by y plus 6. And we're given that alpha beta plus gamma delta is the largest root. So therefore, alpha beta plus gamma delta is 7. So for the next part, we have to use the values of q and s to find the value of alpha plus beta times gamma plus delta and the value of alpha beta given that alpha beta is larger than gamma delta. So if we expand alpha plus beta times by gamma plus delta, we get alpha gamma plus alpha delta plus beta gamma plus beta delta. And what you'll notice is that this is quite similar to the sum of each pair of roots, except that we're missing an alpha beta and a gamma delta. So the sum of the roots is going to be q if you look at the quartic equation, but we're given that q is 3. And we figured out in the last part that alpha beta plus gamma delta is 7, so that's equal to negative 4. So now if we look again at the original equation, we know that s is 10, and we know that the product of the roots is going to be equal to s. So we're going to have that alpha beta gamma delta is equal to s is equal to 10. So now we've got a relationship between the product of alpha beta and gamma delta and the sum. Now remember Vietta's formulae. Alpha beta and gamma delta are going to be roots of the quadratic t squared minus 7t plus 10 is 0. This factorizes to t minus 5 times by t minus 2 is 0. And since we're given that alpha beta is larger than gamma delta, we get that alpha beta is going to be 5 and gamma delta is going to be 2. Okay, so for the last part, we have to use these results and the values of p and r to solve the quartic equation. So you'll notice again that p is 0 and r is negative 6. So p is going to be the negative sum of the roots, or in other words, the sum of the roots is going to be negative p, so 0. And similarly, we know that r is negative 6, and r is going to be the sum of combinations of the products of 3 of the roots. So alpha beta gamma plus alpha beta delta, alpha gamma delta plus beta gamma delta. That's going to be equal to negative r, which is 6. So we can factor out alpha beta from the first two terms to get alpha beta times gamma plus delta. And we can factor out gamma delta from the last two terms to get gamma delta times alpha plus beta. We know that alpha beta is equal to 5. So we get 5 gamma plus 5 delta. And similarly, we know that gamma delta is 2. So we get 2 alpha plus 2 beta is equal to 6. Now I'm going to call this equation 1. So 2 times equation 1. And I'm going to call this equation 2. So this implies 2 alpha plus 2 beta plus 2 gamma plus 2 delta is 0. And we're going to do equation 2 minus this, which gives you that 3 gamma plus 3 delta is 6, because the alphas and the betas are going to cancel out. Or in other words, gamma plus delta is 2. We can now perform the similar trick that we performed in part 2, because the roots are going to satisfy the quadratic equation t squared minus 2t plus 2 is 0. So t is equal to 2 plus or minus the square root of b squared minus 4ac over 2a. So that gives us 2 plus or minus 2i over 2. Or 1 plus or minus I. So since we now know that gamma plus delta is equal to 2, we have that alpha plus beta is equal to negative 2 using equation 1. Again, we know that alpha beta is 5, so a similar trick tells us that alpha and beta satisfy the quadratic equation t squared 2t plus 5 is 0. So t is going to be equal to -2 plus or minus the square root of b squared, which is 4, minus 4ac all over 2, which is -2 plus or minus 4i over 2, or -2 plus or minus 2i. So these are going to be our final answers. So how did you find this question? Let me know in the comments below. If you enjoyed, please like and subscribe, and share it to a friend to see if they could solve it too.